For years, astronomers believed they understood how interstellar comets behave. They brighten when they get warm. They shed dust. They flare occasionally as buried ices explode into space. Simple, predictable, ordinary. But then came 3I Atlas, the strange, shape-shifting, rule-breaking visitor from beyond the solar system. And now, a new observation has shattered everything we thought we knew about it. For the first time, we've captured a close-up of a massive solar-triggered flare erupting from the surface of 3I Atlas.
3I Atlas has been in interstellar space for a very long time. There is circumstantial evidence, given how fast it has come in to our solar system, that it came from some very old population, solar system around a very old star. Quite possibly, we can't say this for sure, but the likelihood is it came from a solar system older than our own solar system itself.
And what it reveals is unlike anything ever recorded from a comet. This wasn't just a geyser of vaporizing ice. It wasn't a dust plume. It wasn't a normal outburst. What astronomers witnessed looked more like a miniature eruption, bright, violent, structured, as if the comet responded to the sun with a force far greater than its fragile body should allow. The discovery began with a routine observational sweep as 3I Atlas approached the inner solar system. Ground-based telescopes were tracking its brightness curves. Small fluctuations, small jets, nothing unusual. Then, in the span of less than 30 seconds, the comet's light signature exploded. A sudden surge, a violent flash, an eruption 10 times brighter than anything detected from this object before. At first, scientists assumed it was a glitch, maybe a faulty sensor, maybe a passing satellite contaminating the reading. But then more telescopes, thousands of miles apart, recorded the same event. A real flare, a colossal one. And that's when things got strange. The flare didn't look like a typical comet outburst. Instead of scattering outward in all directions, the material erupted in a tight column, a focus jet that bent toward the sun, not away from it. As if the comet were reacting directly to solar radiation, or absorbing it, or being triggered by something buried deep inside. Comets normally release gas symmetrically, like a thawing snowball. But this looked like a directed response. NASA immediately retasked multiple instruments. The European Southern Observatory followed within minutes. And for the first time ever, the solar flare from an interstellar object was captured across multiple wavelengths: visible, infrared, and even ultraviolet. What they saw shocked everyone. Inside the flare, there were rapid temperature spikes, far higher than expected for a chunk of fragile ice floating in space. The jet contained minerals that shouldn't be vaporizing at that distance from the sun unless something highly energetic was happening beneath the surface. Some compounds appeared crystalline, others metallic, and some, bizarrely, showed spectral fingerprints that don't match any comet ever observed in this solar system. This wasn't just a flare. It was a chemical fingerprint from another star system, being blasted into space like a cosmic confession. But the most surprising part came when researchers slowed the footage. Hidden inside the eruption were microstructures, small, repeating patterns of dust and ice that looked strangely organized. They had symmetry, flow, almost architectural shapes. Not artificial, but not random either. They resembled the shapes seen in extremely cold crystallization processes not found in our solar system. If this flare exposes the internal structure of 3I Atlas, it means this object is not just foreign, it's fundamentally different in composition. The flare lasted only minutes, but the after effects lingered for hours. The comet's brightness curve shifted. Its rotation changed slightly. The tail reoriented. Something deep inside 3I Atlas had been disturbed, as if the flare had unlocked or exposed a new layer of the nucleus. Astronomers expected one flare. They got 3. Within 6 hours, 2 more eruptions occurred, weaker than the first, but still far stronger than anything produced by a typical comet. And each flare produced a different chemical profile, suggesting multiple pockets of exotic material buried inside the nucleus. It's as if 3I Atlas is a layered archive from another world, each flare revealing a different chapter. Astrophysicists immediately began looking for explanations. Some theories emerged quickly. One group believes the flare originated from volatile ices never before seen near our sun, exotic compounds formed in the coldest regions of interstellar space. When those ices met sunlight, they didn't sublimate gently. They detonated. Another group suggests the flare came from internal stress fractures. Imagine a frozen world cracking under its own rotation, releasing pent-up pressure built up over millions of years. But the most controversial idea came from researchers studying interstellar dust. Certain dust grains in deep space can trap energy, electrical, magnetic, or even radiative, for extremely long periods. If 3I Atlas contains these energy-storing minerals, then approaching the sun could trigger rapid discharges, creating flares far more intense than normal cometary outbursts. In simpler terms, the comet may have spent millions of years absorbing cosmic radiation in interstellar space and is now releasing it. But the moment NASA released the infrared maps of the flare, everything changed. Inside the eruption were traces of carbon chains so complex that they bordered on prebiotic. Not life, not anything close to organisms, but chemical structures that some researchers believe might be precursors to biology in certain star systems. This is the first time such compounds have ever been detected in an interstellar object. If these chemicals formed in a distant solar system, it means alien chemistry has now arrived at our doorstep, and we're watching it explode into space in real time. But the strangest part of the breakthrough came from the timing of the first flare. The exact moment the eruption began corresponded almost perfectly with a sharp increase in solar activity, a small but measurable burst of solar radiation. It's as if 3I Atlas heard the sun and answered, not in any intelligent sense, but in a physical, reactive way we've never seen in a comet. Its internal materials responded to the sun like a trigger, like a chemical switch being flipped. And if that's true, then 3I Atlas is not just a visitor. It's a reactive, dynamic, volatile object, a ticking archive from another world that only comes alive under the right stellar conditions. The flare revealed more than chemistry. It revealed structure. When the jet shot outward, high-speed imaging captured shadows that hinted at internal cavities inside the comet, hollow spaces, possible tunnels, or fractures that run deep into the nucleus. These aren't artificial, but they are unusual. Most comets are porous snowballs, but 3I Atlas appears to be filled with chambers and pockets, like a layered geological body. Some scientists think this structure means the comet formed in a chaotic, violent environment around another star, a place with extreme cold, intense radiation, or rapid changes in temperature. Others believe it may have formed near a massive young star, where dust was compressed into sharp layers by strong stellar winds. But one idea stands out. 3I Atlas may not come from a typical planetary system at all. It may originate from a rogue planet, a world ejected from its star system billions of years ago, drifting alone in the dark, where unusual chemistry could flourish. If that's true, then this flare is the first direct evidence of rogue planetary chemistry interacting with our sun. The implications are enormous. Each flare from 3I Atlas is like peeling back a layer of cosmic history, a flash of light revealing materials forged in environments we may never reach. Every eruption teaches us something new about the physics of interstellar objects, how they evolve, how they store energy, how they fracture, and how they respond to new stars. But more importantly, each flare is a warning. This object is unstable, volatile, a frozen grenade drifting through our solar system. Its close approach could trigger even more powerful eruptions, possibly thousands of times larger than the ones we've already seen. Astronomers are preparing for that moment. They've scheduled continuous monitoring. They've activated deep scan radar. They're analyzing every eruption frame by frame, trying to understand the internal structure before the comet gets too close. Because if a flare this powerful happened closer to the sun, it might tear the comet apart, revealing its entire interior in one violent blast. And that might be our only chance to understand the true origin of 3I Atlas. It's not just a comet anymore. It's a message, a warning, a relic, a volatile archive from a forgotten star system. And now, after this stunning close-up of its first solar flare, the world is finally beginning to understand the truth. 3I Atlas isn't just visiting. It's awakening.